Hello and welcome to honors function. In this video we're going to be looking at how to write a subset of the set of real number called intervals. This is a very important types of subset of the real number. So what is an interval? So to describe this, let's look at the real line. This line represents the real line right here. Suppose we have here a number a and here a number b. When you were in some algebra courses, you have denoted some subset like this, for example. What would this be? This is the set of real number such that x is greater than a and at the same time smaller than b, right? Well, if you use interval notation, you would be writing this as a b. Okay? So what is ab? All the real numbers between a and b, not including a, not including b. Okay? Now, if you want to include either a or b or both, for example, this one right here, okay? How would you write that? Well, you wouldn't be putting a parenthesis on a, but you would be putting a bracket a, b, and here a parenthesis on b because it's open, okay? So we say here that the interval is open. Here we say that the interval is closed, all right? AB, either here or there, AB are called the endpoints of the interval. So AB is the endpoint of the interval. Here you have an open interval, okay, because it's open at both endpoints. A closed interval would be, for example, this right here, AB would be a closed interval. So of course this is just, here's A, here's B, this is closed on A and closed on B right here. This one right here, it's just called a half open, or you can also call it a half closed interval, okay? Now these, okay, so we have an open interval, a closed interval. Here we opened it on the right and closed it on the left. You can also open it on the left and close it on the right, okay? These four types of intervals have two boundaries. There are also a type of interval with only one boundary. So let me show you. For example, here's the real line, here's A, and I would like to describe this set. So this is an array, right? We write it as, so it's open at A, right? So A, and then it doesn't end on the right. So if it doesn't end, we put infinity. There is always a parenthesis around infinity. Around A, you don't have to have a parenthesis. You could also be describing this set right here, in which case you would be putting a bracket around A, okay? So these sets only have one boundaries. Finally, you could also write the set of real number as an interval, so it would be negative infinity to infinity, okay? So this is using the letter for the set of real number, and this is using the interval notation. Okay, let's go over some problem. Before we do that, I just want to define a type of terminology I'm going to be using all along. This A smaller than B or A above B, I will call that a strict inequality. This is the way we call it in math, actually. It's not just me, okay? Strict as opposed to what? As opposed to a large inequality right here. This is called a large inequality. So a large inequality is actually a conjunction. A large inequality, like this one, for example, stands for what? It stands for A smaller than B, a strict inequality, or it stands for A equals B, okay? This is just a notation for this disjunction right here, okay? All right. Let me now go over some examples. All right, let's start with the first one. This is a union, the union of two sets. The first one is -1, 5. So this is very simple, okay? I'm spending time here, but this is very straightforward. Here you go, you got -1, 5, right here. You shouldn't illustrate it all the time like that. I'm doing this because it's the first one. It's make things easier. What about the second one? Well, the second one is just a singleton. A singleton is a set with one element. Here we go. That's it, right here. Okay. So what happened when you take the union of both? Well, if you take the union of both, -1 is not included in that set, right? -1 is not an element of -1, 5. So what happened if you introduce it to that set? Well, you're gonna be closing the boundary at -1, and it's just -1, 5. That's it. Okay. All right. I'll let you do number 2. I'll let you do number 3. Let me do number 4 right here. Okay. So what's going on here? Here, it's gonna make it easy maybe if I do a drawing, although you really don't need to. Okay. I do advise you after a while not to do the drawing. So you have -2, 0, 3. I'm putting all of my boundaries. So -∞, 0. Here's a ray right here. And then we have -2, and it's closed here, until 3, and it's closed here too. And I'm taking the intersection of both sets. So I see where the common elements are, right? You need the common elements right here. So the boundary of the intersection is going to be -2, 0. At 0, what's going on? Well, 0 is not in this one right here. It is in this one right here, okay? But it's not in the bottom one, therefore it's not in the intersection. How about -2? -2 is in this one right here. It's closed here, and -2 is also in the ray. So -2 is in the intersection, okay? So here we go. This is the intersection of both sets. All right, let's continue. In this example, I'm taking two sets A and B. Let's first represent them. Here's my real line. I need the boundaries -5. I'm going to put it here. I need the boundary 4. And it's an open set. So A is -5, 4. This is A. While B is 3 infinity. So I'm going to put 3 right here. It's not drawn to scale, and that doesn't matter. And then I'm going on forever here. I'm going to change colors. So B, it's closed 3, and then on forever towards infinity. That is B. So now I want the intersection, the union, the difference A minus B, and the next one is the difference B minus A. So I'm only going to do one of them. I'm going to let you do the other 3. I'm going to do number 9. I want A minus B. So A minus B are the elements that are in A but not in B. So where do we start? We start at -5, and these elements are all good, right? Because they are in A but they are not in B. And you have to stop right here. You have to stop at 3. Because if you go further, like if you take this one right here, this is an element in A, so that's good, but it's also in B. You don't want that. You need to eliminate all of these, okay? Question, am I filling in the circle or not? No, you can't fill in the circle because you don't want to be in B, and 3 is in B. Okay, so A minus B is the set -5, 3, open at 3, open at -5, the open interval. Let's move on to the next example. Okay, let's finish with the last series of examples. So I'll do 11 and 13, and you'll do the other 2. So this is a very short video, right? We need to write, this is a set notation right here. This is set notation, okay, set notation, and we need to use the interval notation. So what is this? All the x's, if I don't specify where I mean x in R, okay, they're all real. Interval is a subset of the real number, okay? Here, actually, I'm thinking of a problem before continuing right here. It's a subset of the real number. So, for example, what happens if you do 2, 3, and you intersect that with z? What is this? What are you going to find if you do this? You get it? Yeah? All right, let me tell you. Maybe you have it. I hope you do. It's just 2, right? There are no other elements in 2, 3, the interval 2, 3 with z. The only integer in 2, 3 is 2. All of the other numbers are not integers, okay? All right, that was just a parenthesis here. So I want all the real numbers such that x is not equal to -2 or x is not 0. So if you represent that, that's very simple, right? It's everything except -2 and except 0. Here we go. That's the set I'm looking for. So to write it, it's pretty simple. -∞, -2, union, that's this one right here. Then I need this one right here. Union -2, 0. And then I need this one, union 0, infinity, right? So the union of these three intervals represents that set right here. Let me do number 11. I want all the real numbers that are above -2, but not equal to 0. So above -2 would mean -2 infinity. But then I need to remove 0 from there, right? So how do I do that? Well, that set is just -2 to 0, union 0 to infinity. We could also say like this, but this is not interval notation, right? This is a subtraction of two sets. I can write that as one interval, so these two are equal, but I ask for interval notation, therefore I want this. Okay, that's it. Thank you for watching.